Hey everyone, welcome back to my YouTube channel. So today I'm gonna talk. In fact, I'm gonna start the new series on most important question of PYQs, a previously asked question from the GATE examination. So what I decided here is that I'm gonna take question from GATE 2022 because this paper was one of the very wonderful paper, right? Which surprises many people, right? I'm gonna take the question from communication system, right? Usually this algorithm is not discussed anywhere in the class, right? And what I have analyzed from the paper is that whenever I teach this topic or this subject communication system, so I usually talk about this algorithm, right? This algorithm name is LLOYD max algorithm, right, which help us to design optimal quantizer, okay? Because we are directly familiar with what the uniform quantizer, we are different kind of quantizer we are familiar with, but we are not familiar with LLOYD max algorithm or LLOYD max quantizer. So this question was asked from a communication system in GATE 2022 for 2 marks. So today I'm going to see we are going to see in fact the LLOYD max algorithm based question. So let's move to the slide directly. um, this question was asked in GATE 2022, as you can see in the thumbnail, right? And also you will get surprised that this topic is not covered, okay? I mean, this concept is not covered in the classroom anywhere, if right. Today you are getting very good concept, right? So I'm not going to talk in detail about LLOYD max algorithm, just in brief. So LLOYD max algorithm, let me erase this and write in the middle, right? LLOYD max. So this kind of algorithm is going to basically help you design optimal quantizers. So what is the meaning of optimal here? Optimal meaning here is to minimize the quantization error, okay? Quantization noise error, which you study in quantization, okay, in PCM chapter. So this basically helps you. It gives what? It gives optimal quantizer. What does it give? It gives optimal quantizer. And what does it mean? What is the meaning of optimal here? Optimal meaning here is that minimizes quantization. Quantization. See, if you know the concept of LLOYD max algorithms, you would be able to solve this question within 20 seconds, right? But if you don't know, so you will start solving from the conventional method and end up wasting a lot of time. In fact, you will not get the right answer also. So whenever you read the question, you should be able to recall from which concept this question was asked, right? So if this topic is not covered, please make the note of it, because in GATE 2023 again few important questions will be asked. Make sure that entire subject should be covered, right? So LLOYD max algorithm says here is that it gives optimal quantizer and it minimizes the quantization error, right? For optimal quantizer, what we need is we need some intervals, okay, and we need to choose what? We need to choose some quantization levels, okay? It need not to be necessarily that the quantization level is in the mid of the boundaries, okay? Suppose this you know these are the intervals. You can say m naught 1 l, and you can choose the these are the what? These are the intervals. These are the quantization and here you can choose the you can say alpha 1, okay, alpha 2, L. These are the labels you can choose, right? So these alpha 1, alpha 2, alpha L is the quantization. They are the quantization. So what Lloyd Max algorithm says here is that if you want to minimize the quantization error, or you can say the square quantization error, mean square quantization error, not only the quantization error, then what you can do here is, if okay, if quantization intervals are given, okay, if quantization intervals are given, suppose quantization are given, right? So you can find quantization level, and if this is given, right? I mean, if quantization level is given, what you can find? You can find the so my question is now, how can we determine, how can we find the quantization level, how can we find the quantization intervals? So for that, in the question, what will be given? In the question, probability density function will be given. You know, because the quantization level, we need to consider it as a random variable, right? So if there is a random variable, so that random variable must be characterized by the probability density function that we know already, right? So in the question, the density function will be certainly given. So you can say some density function is given here. Just I'm considering any. So this is a density function. This kind of a density function is given, and here you can choose the uh, quantization intervals. You can choose the quantization interval from here. M naught, 1 and 1, right? You can also choose the quantization levels, alpha 1 or 2. So what you can do here is, you can say that this alpha k, this alpha k lies between what? This alpha k lies between, you can say, mk minus 1 to, you can choose k for k intervals. So suppose there are k intervals. I have taken L interval, but you can consider k intervals. If you will choose alpha k in this interval, then the quantization noise error will be minimized. So what will be the how we can formulate, how can we find these levels, quantization level, right? So what you will have to do here is, you will have to consider this, this density function. Okay, the question it will be given, just I have there's some general density function, right? So this is, suppose this is your m, this is the density function, and you have to choose the quantization intervals, then you have to go for quantization level. See, in case of uniform quantizer, we always choose quantization level in the mid of the boundaries, right? But in this case, we cannot choose in the mid of the boundary. There will be one interval, so anywhere in the interval we can choose the quantization level, okay? And that is going to be helping you to minimize the uh, required mean square error. So when you will when you will follow Lloyd Max algorithm, okay, when you will try to minimize it, means in the mathematics we have studied that if you want to minimize any function, right, so what you will have to do, you will have to take the derivative of that and equate to 0. Okay, so you will get final result, I'm telling you, right? Final result, I'm telling you, if quantization level is given, remember, sorry, if quantization interval is given, so you can find the quantization level, and if quantization level is given, you can find the quantization interval. So this is the iterative process, okay? With the help of iterative process, we can find both the things. So after all, we have to solve the gate question, right? If we know the formulation, okay, if we know this alpha k, okay, if we know this alpha k, right, this alpha k can be determined. Remember, this is very, very important result, okay, from the Lloyd Max algorithm. This alpha k can be determined with the help of what? Conditional expectation. With the help of conditional expectation. So this alpha k can be determined with the help of conditional expectation. What will be the conditional expectation? You know, m, and this m should belong from what? This m should belong from the quantization level given, or I mean quantization interval given, right? M minus 1. This is the result. And what is going to be the result here? So let me write here. Yeah, here I am writing, right? So alpha k can be written now. You know, if density function will be given, so you can integrate that density function and weighing, okay, weighing with the help of this density function times m, and this integration will be from m k minus 1 to on the total probability, okay. Total probability in that particular interval from minus 1 m in mk f. With the help of this quantization level, you can really minimize the quantization. So I will write again alpha k value over there. So this is also you can say this is also known as conditional expectation, right? I will create one separate video on LLOYD max algorithm. I will explain you how we are getting this result, okay? Alpha k, which is integrating from mk minus 1. This is the chosen quantization interval, or given, you can say, okay? So in the question it will be mentioned that this alpha can be chosen from this interval to this interval. That much time, right? So here again I am writing. So after all, this result will be useful. Alpha k can be determined from to mk m. Density function will be given m. This is capital M, okay? After all, your quantization level is random in nature, so we are characterizing random. Let's move to GATE 2022 questions. Question was asked in GATE in ECE paper from the concept, I mean quantizer, or you can say the from subject communication for 2 marks. So let's read the question, because reading the question is very important. Whenever the question is on the screen, what reading first, and while reading you have to fetch the information, right? Let's read the question here. Consider here, let me choose different color. Consider a real valued source, okay, whose samples are independent, identical, and independently distributed, okay, independent and identically distributed random variable with the help of and with the probability density function, right? So here the sample signal, the probability density function is given for the sample signal, right? Okay, this f of x is given from -2 to 1. Okay, here the triangular profile is given, here the rectangular square profile is given, you can say, or rectangular profile, whatever you want to call it. And consider a 1-bit quantizer that maps positive samples to alpha. You see here 1-bit quantizer we have to consider, and that maps positive value to alpha. Means alpha, for alpha we need to choose, yes. So this density function is given, right guys? So what we can do here is let me write the density function here. So density function is else, okay. Find this maximum value of this density function, that is the area, that is 1 by 2. This is the triangle here, that is, you can say that this is 1 by 2. Now you can write f of x for x from -2. Here this is there is a slope, right? So you can say that that slope will be 1 by 4x by 2. This equation you will get in the interval -2 to 0, and from 0 to x, I mean 1, you will get by 2, because that is constant. And I hope this is clear. Now you have to find, let me get back to the question. This is the question given, okay? Till now I did not talk about anything, right? Now what they are asking is 1-bit quantizer that maps positive sample to value alpha and others to value beta. if alpha star and beta star are respective choices, okay, according to the Lloyd Max algorithm, if these are the respective choices for alpha and beta that minimize the minimum, that minimize the mean square quantization error, then alpha star minus beta star. What you can do here is, so this is the beta range we have to find, take, and this is the alpha. Now whenever you want to level, because in the question quantization interval is given, these intervals are given, as I said, level, right? Yes. How? Alpha star. Now you are going to compute quantization level for what? The particular interval. So you can choose alpha in the range to 1. So alpha star is basically the conditional expectation. We are conditioning on this density function. So alpha, okay. So alpha star can be computed like this. You don't have to differentiate now, because after all we are using direct result of Lloyd Max algorithm, okay. You don't have to do any math now. So you can integrate now 0 to 1 and x times what is in this interval, what is the density function over 0 to 1, it is 1 by 2, so by 2 d on 0 to 1. I hope this is clear for everyone. So going forward, right, going forward, if you will compute this, okay, so what you're going to get here is that you will get x square by 2, 1 by 2, 0 to 1, okay, because if you will integrate x, okay, so x square by 2 will be 1 by 2, and this is going to be 1 by 2, right? So 1 by 4 by 1 by 2, that is 1. Now it's time to compute beta star. So let me write this, not be able to see. Alpha star you have. So here again from -2 to 0 we have to integrate f of x -2 of x. So as we know that in this interval from -2 to 0, okay, from -2 to what is given here is that -2 to 0. This is the density function. So let me put here everything, minus x times of 1 by 4 of x. If you know this result, right, from the Lloyd Max algorithm, you would be able, and I will create one different session on which I will be discussing how to get this particular expression for quantization level to compute, right, so that you could optimally design the quantizer and can get the minimum mean squared error. So if you will compute this, right, so you can easily compute this. I think okay, let me tell you only, -2 to 0, this is going to be x square by 4, right, plus 1 by 2. I think this integration is very fairly straightforward. In fact, -2 to 0 will be 1. Again, here you can plug this only, 1 by 4 right over there. So let me solve this so that you could find very easy. -2 by 4 for x. Only calculation is there, that's it. So I think you will be able to solve this. Okay, so if you are going to solve this, what will be there? 1 by 4 by 3. on, this is going to be 1 by 4. Okay, so you will solve this, you will get here as minus 2 by 3 if you will solve everything, right? So I think you can solve this integral. Yeah, so or we can compute for you. I think so 1 by 4. This is basically 8 by 3 because minus 2 if you will compute over there, and 1 by minus 4 by 2 on 1 by 4. So further if you will compute, so it will be 8 by 12 minus. So why I'm not cancelling this 4 and 4, there is a reason. By 2 here you can cancel. So here you can make 12 okay in the denominator as well, so multiply by 3, 8 minus 12 upon 1 by 2. If you will go ahead, and will give you minus 4 upon 12, this will give you what? By 3. This is, so you can say minus 2 by 3 you are getting the star. So what they are asking is, they are asking alpha star minus 1 by 2 was alpha star minus of minus. I hope this is clear for everyone. We'll meet in the next session again. Okay, thank you so much. So we will catch up in the next session with the new question and the new concept. I will discuss and everything detail for LLOYD max algorithm. I hope you might have liked this.